Now this equation came after realizing earlier that there used to, you people have heard of this, right? Constant life Haig diagrams, minute Haig diagram, constant life diagram during your execution of project. Yes or no? Yeah, Haig diagram is this is an expansion form because the Haig only invented when started this one. So you generally have a SN because earlier this again SN curve is the material properties, and they generated this some chart or this. This is what SN curve is, either S max or stress amplitude number of cycles. But you generate a constant life diagram between the stress amplitude and mean stress in line with what Goodman equation we found that here S max is there, different R is there, so one can convert to stress amplitude using the equation, and mean stress is nothing but R is the mean stress, we can get that. Now the constant life means what it says, you can see that plot, open hole, solid this cross, then triangle, open triangle and open square. What it actually says is the combination of stress amplitude and mean that gives this, so this is square is what, 10 to the power 6, right? So there is a always there is a combination of stress amplitude and mean which will result into 10 to the power 6 cycle. So to get a higher mean, to get a 10 to the power 6, then your stress amplitude decrease. So that means here, suppose the example 20 I take here, and mean is 10.5. So mean is 5 psi and is close to 20. That will give 10 to the power 6 cycle. Similarly, if you take somewhere here 0 to 15, this line 15 stress amplitude, but combination has to be 35 of the mean, then only 10. So the locus of point connecting points which results the combination stress amplitude and mean stress gives 10 to the power 6 is known as constant life. Life is the constant for 10 to the. So you have similarly for 10 to the power 4, 10 to the power 3 and 40,000 cycles and all. Again is a metal pipe, but imagine to generate this you have to generate lot of tests. Okay, since it involves effort and expensive thing, then only Goodman and Gerber and all they came out with the equation, empirical formula that amounts to same thing. But sometimes this earlier this that is available because it is easy to get quickly some answers. How? Okay, before going that, there's a master fatigue diagram also available. You have this mid-range means nothing but mean stress versus alternating stress, stress amplitude, again plotted with your S max and S mean. Then you have a both amplitude ratio and stress ratio variable. So this is a master chart giving that. The idea is if you have a some indication of stress amplitude or S max or stress, any one of them is known, 2 parameter out of 3 you should know 2. In that case, if the curve, this is the material properties, if the curve is there, quickly you will be able to come out the conclusion what should be the life. Of course you need to do, this is again material properties, some factors to do, but after that you can have a scatter factor to get that, but there is a quickly one can get answer. So as long as any stress combination of stress amplitude and things less than 10 to the power 6 endurance limit, this is for ferrous material, that's why you have a very safe infinite life. But you cross 10 to the power 5, not safe, it will have finite life. 10 to the power 4 again it will find, 10 to the power 3 you are not going because that will go to the low cycle fatigue. So anything beyond 10 to the power 6 will have a finite life, not safe means finite life. We'll see the applications, how it is been done. You can see 7075 T6 sheet ultimately for that material is the material properties. It is generated an axial load, room temperature, electropolished finish. See, this is again material SN curve with electrofinish finish. But if you are trying to predict the life of component which is not electrofinish, obviously it will have a affected endurance limit. Anyway, that will sit down the line. Now, if you know this curve as a thing, you know the S max is some 50 megapascal and stress ratio is minus 0.2. You want to know, of course, you can use Baskin equation also to find out that. That needs some calculation. You have to look for A and B constant and substitute, then simplify it. But if you know 50 with 0.2 minus 0.2, so what is the S max is 50 means what will be the S mean? R is equal to S mean by S max. So if S max is 50, what is S mean? For minus 0.2. Yeah. What? Yeah, 5 to the 10 minus 10. So you draw here minus 10. You have knowledge of 15.2, of course, I mean the manual thing with its curve is coming, I mean they are matching, not that there is a some discrepancy. Okay, you know the loading which has got a 0.2 stress ratio 50, so you go to 50 line here for same as 0.75, 0.2 stress ratio is meeting what 4 in 10 to the power. So you know that life will be not going beyond 4 10 to the power. It may be less because you have to use scatter factor. So that's quickly you got the answer. This is one way of doing it. And of course, once you know S max, you can find this thing. Another one is where you have stress amplitude, you know, and mean you also know. Okay, so stress amplitude 20 and mean equal 30. Okay, if you it's cross crossing, so it's hitting is 0.2 as the stress ratio. Stress amplitude is what? S max minus S min by 2, and the mean is S max plus S min by 2. By simplification you can get the R, but directly it will come to hit in 0.2. And if you see, and where it is intersecting, this is 10 to the power 5. So you will get a cycle of 10 to the power 5. And what is the S max? 50. S min 0.2 means 10. Positive side 10. So that is one advantage. For this is again, it is done for smooth solution, and again 70615, and this is a material properties. See AICI also 4340. They have also generated for notched also constant life. So all combination of stress amplitude and mean will give the 10 to the power 6 in notched specimen. We will have a different KT. That's a different issue. For unnotched smooth specimen, the combination of this will give any line under that will give the 10 to the power 6 and 10 to the power cycle. Okay, this was unnotched, and is calculate for KT equal 3.3. This one. So you imagine for different KT to find out what is the cost. So it involves